Alrighty, Algebra 2, video 20.1, factoring. Oh Lord, it's a factoring part 1 too, sorry. Yeah, it's one of those topics. Alright, so video 20.1, factoring. Alright, here's example 1. Okay, all of these will say factor today. Okay, alright, the very first thing you want to do when you look at these expressions, okay, and it says to factor it, is you're looking for what we call a GCF. Okay, you've heard it many times, it's called greatest common factor. All right, and you're looking through the two terms here. You see 5, you see 30. You know, what is the largest factor? 5 can divide into 5, 5 can divide into 30. So far your GCF is 5. And then when you look at the letters, okay, you got x to the third, which is x times x times x. You have x to the second, which is x times x. But because it's greatest common factor, you're looking for the greatest amount of x's that's in both, okay? So even though 3 is more than 2, you're going to go with x squared because x squared is the most that both of them have. So this one has exactly x squared, this one has x squared and one more, so that's why the greatest what's in common, okay? Once you have the GCF, I'd write it off to the side in a box, and then what you're going to do is you're going to divide by that GCF, whatever it is, okay? And then you're going to divide. 5 divided by 5 cancels. And then look here, you remember when you are dividing monomials, you subtract the powers. So this will be x. Remember there was one extra x. 30 divided by 5 will be 6. The x squares will cancel. You'll wrap this in parentheses and put your GCF 5x squared out here. All right. You can check it because basically really what you're doing is you're just doing reverse distributive property. So if you were to take this GCF and distribute it through here, you would go back to the original problem, because really all factoring is we're kind of undoing the expression, right, by division. So let's just take a look. X squared times x would be 5x cubed, you're back there. 5 times 6 would be 30, keep the x squared. Yeah, if you distribute this answer, you go back to where you started. Okay, all right, keep that in mind. We're going to do one just like that one. Let me spin this real quick. All right, so GCF, I'll draw my little box over here because honestly I've got nothing better to do. All right, 3 and 27, what's the biggest number they have in common? 3 can go into 3, 3 can go into 27. Here you have y times y times y, here you have y. So y squared is the most you have in common, okay? Take it and divide by the GCF. Okay, now we're gonna see what we're left with. Here the 3's cancel, all the y's cancel but 1. Here, what, 3 and a negative 27 is minus 9, but the y squareds cancel completely, and then you just put the 3y squared out here. If you were to distribute this, you'll go back to the original problem. All right, let's do one more like that, just to make sure that we're good. One more with the GCF, then we're gonna do my favorite type. All right, so here we go again. All right, GCF, draw your box over here. 3 can go into both. All right, and is that gonna be m squared? Well, it can't be m squared because m squared can't divide into m. So what is the most each of them has in common? They at least have one m, so it's going to be 3m. You're going to divide by 3m, you're going to divide by 3m, and let the party begin. So this first one, the 3's cancel, you're left with one extra m. Here, this is what, 9, close the parentheses and put 3m out here. Let's just double check. 3m times m, 3m squared. 3 times 9, 27, keep the m. Yeah, it looks good to me. Get in the habit of looking for GCF, even though there's a big group of factoring that there won't be, other than one, which is where I'm going to the next example. All right, here we go, more fun. So example 4 here. look, you got x squared, you've got x, you don't have an x over here, so you can't pull an x out. You can't pull a 2 out or a 4 out of all three. You can pull a 2 out of these two, but not all three. So this one doesn't have a GCF factor that you can pull out. If you notice it's a trinomial, immediately go ahead and do your 2 sets of parentheses. We're going to see if it'll factor into a bi times a bi, okay? How do you get x squared? There's only one way, it's x times x. Okay, come over here and you circle 12. Okay, your constant, you're going to list factors of 12. So there's 1 and 12, there's 2 and 6, there's 3 and 4. You're going to pick the winning couple here that adds up to be the middle coefficient. So in other words, what factors of 12 add up to 8? Well, yep, 2 and 6. I heard someone say that. It doesn't matter where you put the 2. It doesn't matter where you put the 6. Okay? Signs are positive, so signs will be positive. Okay? And again, like in the previous example, if you were to double distribute this out, you would end up with this answer. And I'll show you in a minute. If this is positive, positive, this will be positive, positive. Okay? Kind of got you there. All right, let's have you try one then. Yeah. Because it looks like the excitement is there. All right, again, all of these are factor. All right, do you have GCF? Always check for GCF. Nope, I don't see a GCF. So go ahead and try with the parentheses, because it's a trinomial. You got your n here and your n here. Okay, cool. All right, good news. 2 is prime. It only has 1 and 2 as factors, so it's got to be that if it's going to work. Okay? All this positive tells you is the signs are the same. You know, because you multiply to make that 2, so it's either going to be positive, positive, or negative, negative, right? That's all it tells you the signs are the same. But when you come here, you don't want a positive 3n, you want a negative 3n, so you're going to make these both negative. Okay, I'm starting to see some doubt in your eyes, so hold on, I'm going to circle this for just a second. That is the answer, I swear. So what I want to do is I'm going to FOIL this out, multiply it out, and let's just see if you guys see what we're doing. We're just going backwards, basically. So n times n is n squared. N times negative 2 is negative 2n. This is negative 1n, and then this is positive 2. We're good so far? Okay. And then when you combine the middle, look, you finally get n squared minus 3n plus 2, which is what we started with, okay? So you're basically, you know, you guys have heard FOIL before too. I just call it double distribute, but it is FOIL. If you took that and worked it out, you get this. We're giving you the answer first, the trinomial first, and you're going backwards, okay? All right, one more. Let's see how number 6 is. Factor, factor, factor. Again, no greatest common factor. You know in the next video I'll find one with a GCF. X and X. All right, here we go. Factors of 16. 1 times 16. 4 times 4. 2 times 8. All right, I'm looking for a pair of factors that adds up to negative 6. Now remember, when I say adds up to negative 6, if their signs are different, it'll actually subtract. But let's add first. Look, 17, 8, 10 doesn't do it. Oh, 15, 0, 6. So here's your winning couple right here. Doesn't matter where you put the 2, doesn't matter where you put the 8. See how this is a negative 16? That means your signs are going to be different. But I want a negative 6, so the higher of 8 and 2, see 8 is higher, has to have the negative, and the 2 has to have the positive. Okay, that is the answer. I do want to show you a quick check though. You can do inner smile, which is 2x, and you can do outer smile, which is negative 8x. And when you add that up, you get negative 6x, and that shows you that middle term right there. Okay, if you want to do that inner smile and outer smile and try to figure that out. Okay, this was factoring part 1. The next video, more fun, more fun. Good seeing you.